Lesson 7. In this lesson I want to show you how to combine machine blocks with AutoCAD blocks. It is a very powerful combination and saves you a lot of time when doing custom items. Let's start with a simple handle. In here the measurement C is 128 mm and B is 35. Let's draw the center line first. We just use simple line commands. Now the center line, because it's 35 mm deep, the handle, we just draw 30 mm. That's pretty much the center line. And the length is 128. And the depth again is 30. As this one is a D handle, we round off the corners. We use the fillet command for that. Give it a radius of 10. Because we want to use the sweep command, we want to convert this into a polyline, or we simply just join it. The join command will do that for us. In order to use the sweep command, we need to draw the section, which is just a circle in this case, with 10 mm diameter, so 5 mm radius. Go over to solid, sweep. Now it asks us first the object to sweep, which is our section. Enter. Then we need to specify the base point. Enter, which is our center. And now this is our sweep path. Select that. So this is pretty much our D handle now. It's a solid. Now we want to use machine blocks to do the drilling part of the handle. So we want to let Analyzer know where to drill the hole. So I personally would change the layer into something like machine block, different color. And we want to attach a machine block to each side of the handle, which basically is the hole that has to be drilled. So for that we draw a box. We want to drill a 5 mm hole, so we have to do a 5 by 5 mm machine block. So it's 5 in width. And the depth of the block is 12 mm and 5 mm high. Now, we don't really want to drill all the way through, but we want to drill from the back face, which is our primary face where the hinges are drilled in the door. So we want to keep a distance to the handle. We just draw a line there. Use the line command for that. We select the center point and we give it a 3 mm distance in this case. So that's where our machine block wants to end. We usually draw a diagonal across. So we have a center line there. We can use the midpoint as a center line. So now we simply move that machine block into the right position, which is this point here. Now we want to copy this over, but first we can actually do the part properties for this machine block. Select the part properties. We make it a machine block and a hole. And now we also have to select an assembly for that. It's not defined yet, so we assign a new assembly. Just use a generated name. I probably will make it screw, it doesn't really matter. This is going to change later to the assembly construction type for the cupboard we want to attach the handle to. We save it. Now we can copy the machine block across. Just use the normal copy command. Select the machine block, our line, and this is our base point. And that's destination point. So now we have those machine blocks right attached there. We delete this. I'll show you how that integrates into a cupboard. For that, it's probably best just to quickly draw a cupboard, which goes really quick. With Analyzer CAD, let's do a simple right-hand single door cupboard. Base unit, one door, right hand. We create a 3D model out of that. Let's say being a right-hand cupboard, we want to put the handle on the left-hand side of the door. So I normally just draw a line across to mark the position. It says 50 by 50, 50 across, 50, and I go 50 down, the Z direction. So that's our insertion point. Now let's move this handle into the right position. Now we select the base point, and this is our destination here. Now let's have a quick look at the plan view. Now we can see where our machine blocks are positioned. Now obviously this is not an ideal situation. Our back face of the door is over here, the front there, so there is actually no entry point. So Analyzer needs to clearly know where he has to drill the hole from, and logically in this situation it would be the back face, since we want to integrate it in the same program that drills the hinge holes. So we can simply move this along here. Now the door could also be thicker, so there's no problem. We don't need to actually be right on the primary face. We can go a bit past that. So I would go another 5mm at least past there. So now our machine block is 17mm deep. We have a 3mm distance from the front face, so it allows for a 20mm thick door. The reason then we're not going through the front face is in case there's a material that's very delicate and it chips. So it's also clear for Analyzer which face it has to drill from. And in case you want to drill all the way through, you can always make this machine block a hole through. So all you need to do is go to the part properties and change this to hole through, and it will drill all the way through. But it's clear defined where the entry point of the machine block is. The other thing we have to do is to assign the machine block to the assembly of the cupboard. In this case we can use an Analyzer CAD command. It's in 3D tools and it says match assembly. You simply press this button. Now in the command line here it asks you select the object for source assembly, so that's any part of your original assembly of your cupboard. You can click at that, and then you have to select the objects you want to assign the assembly to. In this case our two machine blocks. Now before you want to send this to Analyzer Manufacturing, there's one more small change we want to do. We don't want Analyzer Manufacturing to produce this handle here, so we actually want to exclude them from the selection set. So to do that, there is a layer called ANZ Exclude. If any part that's in that layer, that won't be exported to Analyzer Manufacturing, so we simply change this to that. So now it's ready to send it to manufacturing. We run the geometry script, and as you can see now, the handle holes have been drilled. You can double click at them. They are 15.3 deep, so that's 3 mm short of the front face. In order to make an AutoCAD block, we want to copy this handle and the machine blocks into a separate drawing. So we want to open a small block template. This is basically just the very simple original AutoCAD template. It has no layer other than the 0 layer, and no layouts and anything. So it's very simple and ideal to make a block. We open that, and we copy this part. And don't forget the machine blocks and the distance lines. Now Control copy. Go in the block template. Control paste. Now we want to move this block to the exact 0 point, which is going to be our block insertion point. So we use the move command for that. We select the base point, and then we can simply type 0, 0, 0. So it moves us to the absolute drawing 0 point here. So you can see that lines up with that point. Go into plan view, and we want to save this with the block name. We save it as. And you typically save that in a block library, be it on your local machine or typically on the company server, so your colleagues can access those blocks as well. So we call that D handle. (128mm). And that's all you need to do. Now we can test our block. Get rid of the original parts. Now what I would do is I would use the tool palette for this. And you can use palette, and we call it hardware. Now what you can do, you got your block library, your handle drawing, you can drag that simply onto your palette here. See, it even does an icon for you. The good thing about the tool palette is you can actually control how you want to import your block. So when you right click at your block, you can adjust the properties. And in our case, we really want to explode this block when we import it, because we're actually after the 2 machine blocks. And a simple non-exploded block will not have a physical 3D machine blocks in there. They just reference to an internal block that's stored in your drawing file. So we change this to yes, and you can also control the layers and colors and all that. We just use the current in our case. The way you would do it is you click at the block here, and you insert it at the right spot. Now you see this has already been exploded. It's not a block anymore. The only thing we need to do now before importing it to Analyzer Manufacturing is to align the assemblies of the 2 items. So if we look at our cupboard, it has an assembly of base 2. Now our handle possibly has the cab 1 assembly, so we need to align them. Now Analyzer CAD has a command in the 3D tools that's called Match Assembly. So we press that. It asks us here, select object for source assembly. So we select our door. We want to make the objects same assembly, so we select the objects, press enter. Okay, and now they have all the same assembly. Run these to Analyzer Manufacturing. On the geometry script, and our handle holes are there. Quickly double check the depth. Yeah, all okay. Now I want to show you another machine block that comes in quite handy, but let's quickly clean up the drawing. We don't need that shelf for that. We're going to get rid of these construction lines. And it does the drilling according to what's specified in the questionnaire in Analyzer Manufacturing. But sometimes you need to put an additional hinge, or you have another custom situation, let's say a flap in the ceiling or so, where you want to attach the concealed hinges, and you want to have the flexibility to place the hinge where you want it. An AutoCAD block with various machine blocks comes in quite handy there. So let's say in this door we want to introduce a third hinge towards the top, because this door has something attached to it and it's very heavy, and we want to make sure there's not too much strain onto the top hinge. So that's an instance where a third custom hinge would come in very handy. So for that we can do a couple of machine blocks, and I'll show you that how to do now. This is our hinge situation here. It's a 35mm hole as usual, and two 8mm holes, 45 spaced, and 9.5mm from the center. Let's start at the back edge of the door with the construction line. Let's, for simplicity, we start in the middle of the door, and we draw a horizontal line across, and we know the center of our 35mm hole is 21mm from the edge, so we put 21 in there. And that's basically the insertion point there of the machine block. Then we have two 8mm holes, spaced 45 apart, so we can do a line again here, and we run it in the upwards direction by 22.5, and in the downwards direction another 22.5. That's our 45mm part. Now from the center it's 9.5mm spaced out. So we do a move here. Move it horizontally by 9.5. So these ones are our 8mm hole centers. This is our 35mm hole center. Now we want to do the holes for the mounting plates. So we want to make sure that lines up with the center of the hole. So what we can do is we can draw another line here, and we start on our start point. But we want to project that onto the edge of the carcass, the edge of the right hand side. To make sure that we really have the right position, we can use perpendicular snap point. So that has drawn now a line on the edge of our right hand end. Now we know exactly it's on the right height. We can draw now a horizontal line, and we know it's 37mm from the front edge, our mounting plate holes, and they are 32 spaced apart, so 16 up and down. In the set direction. So that's basically all our construction lines. So let's start with the mounting plate holes. We change our layer into the machine block layer. We start drawing our machine block. The depth here is 12. The width is 5. And the height is 5. So that's drawn into the right direction. Again, we draw a line across the face. So we have a proper center point. And we simply move it into position. Now, it's a good idea to assign the part properties for that. It's a machine block, it's a hole. And we can assign an assembly for this. We do our base tool cupboard. So we can test it. Now we copy this to the top. Now we want to draw the machine block for our 35mm hole, so we make sure we've got the right layer. We select box. We want 38mm wide. The depth will be 13mm. And the height is 35 again. We run a line across. And we move it into position. Select center point. This is our destination point. Now we want to assign the part properties for this. Again, it's a machine block, it's a hole. And we use our cupboard assembly in this case. Save it. The next thing is our two 8mm holes. What we do is a simple copy again. Change the properties here. Instead of 35, it's 8. The depth of the hole stays the same, 13. And we move it in place. Part properties are already assigned. This is our spot here. And we copy another one. Okay, so that's all to it at this stage, so it's ready for testing. It's not a block yet, but we can test it now. Then run a geometry script, and here is our additional hinge hole. At this stage it's at the center, and here are our two mounting plate holes. Now we can clean this up. Just clean up the lines that we don't need. We probably want to leave this line here because this is our insertion point here, so that's the one at the back of the door face, and we want to use that as a block insertion point. We can change this into the machine block layer, and I would give it a different color. I'll give it a red color so it's a bit better visible. And maybe to make this point a bit more visible as well, we can probably put a circle in there. And again, we can match the properties of this one. Match properties. Now let's see what else we need to do to make a block out of that. We want to make sure it's adaptable to different thicknesses. So let's have a look at the plan. So what could happen? This will always be at the same spot here. It's always 13mm deep, so I don't think we need to do anything. But what could happen here is there could be a thicker carcass, or there could be a bit more door gap or so. So we really want to make this machine block sticking out a bit more. I would say at least about 6mm, because you could have like 25mm ends or something like that. So yeah, let's go probably about 7mm. And don't forget, there's a second machine block down the bottom. You click here too, and you simply use the grips to drag it out. It still drills about 12mm into it, or a bit more, but as long as Analyzer Manufacturing knows from which face it has to drill, and the primary face in all those cases is always the inside face. Now let's select all these machine blocks and make an AutoCAD block out of it. Same thing. We select the parts, Control C, and then we open up our template, our block template. Control V. So here's our block. Now again, let's move it into the drawing 0 point. Enter. Select our base point. And the destination point is 0, 0, 0. Now let's save this. I call it hinge right hand, because we can mirror this around and make a hinge left hand out of it. Now let's delete this. We try to put our block into the tool palette again. Hinge right hand. Move it there. Now let's test it in our cupboard. Let's move it to the upper part of the door. Use the nearest snap point. Make sure you select the back edge there. Now this should be just under the top hinge that Analyzer Manufacturing assigns automatically. To test this, the only way is to run it through Analyzer Manufacturing. Now you can see it has a hinge hole placed towards the top of the door. In our right hand end, we have the hinge plates drilled towards the top. Now this is quite a simple block here. If you want, you can make it fancy and draw a 3D hinge in there. Same thing then the handle. But I personally prefer it more simple. The drawing gets a bit less cluttered, and it's quite effective and quick to insert. So you can make hinges in different directions, so you don't need to rotate them around. 3D rotate takes a bit of work, so sometimes it's worthwhile for items like this just to do single blocks for different directions, so do a left hand, right hand. In the odd case that you have something, let's say, up in the ceiling or so, you can do a 3D rotate for that. And the other important thing is that you change the assembly of your machine blocks to the part that you want to have it machined to. And that's basically it for lesson 7. Thank you.